Hello and howdy, my fellow mathletes. Root Beer here, looking at question 21 on our Fermat paper. Now, this is the first question in part C. These questions are worth a little more, and they require a little more thought and a little more work. Let's take a look here. What's question 21 have in store for us? The positive integers are arranged in increasing order in a triangle, as shown. Each row contains one more number than the previous row. So I can see that the last digit of each row is going to be what's called a triangular number. And there are probably lots of other patterns here as well. What do we want? The sum of the numbers in the row that contains the number 400 is... Okay. So, we have a couple things to do. First of all, I probably should figure out what row contains the number 400. That seems reasonable. Another thing we should probably do is there a fancy way to add up the rows? If I know it's the third row down, is there a nice formula for that? Because if I can figure that out and say that 400 is in, let's say, row 20 or something, and then I just plug 20 into my formula, and we're all done. So, I think we could probably tackle them in either order. Now, I already said that the last number in each row is a triangular number. And you might not be familiar with what a triangular number is. Depends on how much math you know, how many math contests you've done. Okay, but if you take a look here, the difference between 1 and 3 is 2, 3, 4, 5. To make 10, you could arrange 10 dots like this. And then if I wanted to make 15, just add another row of 5 dots. So these are what are called triangular numbers. And they have a very nice formula. They're the sum of the first few natural numbers. Say all the way up to an n. So the nth triangular number, whose bottom row has n dots, has a formula of n times n plus 1 over 2. If you're not familiar with this, I would suggest perhaps you look up triangular numbers, because they do pop up on contests, and this formula that adds up the first few natural numbers pops up a fair bit too. So it's a good one to know, especially for Fermat papers, Hypatia papers, or Euclid papers, or other math contests like the Canadian Open paper. Okay. So we might make use of this formula. I'm not entirely sure. I think we'll definitely use it to figure out the last digits. Or not the last digits, the last numbers in each row. Because what we're looking for, to find what row 400 is in, we need to find a natural number, not a natural number, a triangular number that is bigger than it, but where the previous triangular number is smaller than 400. That's what we're looking for. So, 400 isn't that big. We could make a guess, or we could just write out the possible triangular numbers. 1, 3, 6, 10, 15, 21, 28. They look like they're growing slowly, but they will start to get a little faster. 45, 55. Okay, and you might say, I'm going to give up after a while. 78, 91, I think is the next one. And that's perfectly fine. If you want to give up and say, well, there's got to be a better way, you could say, okay, 400. You're about equal to a triangular number. What's my guess? Well, I'd need to have 800 be almost equal to n squared plus n, and we could turn this into a little quadratic. And so we could use the quadratic formula to get a pretty good guess. So negative b plus or minus square root of b squared minus 4ac all over 2a. So we're roughly looking for sort of the square root of 800 almost. And so I square root 800, or fill in the whole calculation, and I will get, it's about equal to 28. So I might try 28 into my formula. Okay? So 28 times 28 plus 1 over 2. So that'll be 14 times 29. That's equal to 406. Okay? The 27th triangular number is going to be equal to 378. So what does it look like? Our triangle keeps going down, down, and down, and down, and down. The previous row ends with 378. Then our row would start with 379, 380. At some point you'd have 400, and then 401, 402, and this row would end with the 28th triangular number 406. Okay? So that's what we've got. We're in the 28th row, and this is what it looks like. All the numbers from 379 to 406. Can I add those up? Absolutely we can. One thing we could do is say, well, how many numbers are there? So I'm gonna write this as 378 plus 1. So the previous row's last number plus 1. 378 plus 2. 400 is 378 plus 22, and then plus 23. And then 406 is 378 plus 28, because we're in the 28th row. Okay? So what we've really got are 28 numbers, and I want to add them all up. Okay? So what can I do? Well, I'll take out 28 copies of 378, and what's left over? 1 plus 2, then plus a 3, all the way up to 22, and keep going all the way up to plus 28. So we've got 28 copies of 378 plus 1 plus 2 plus... But we have a formula for this. I said it a couple pages ago. It's a good formula to know. It's going to help us with this question. You don't have to use this formula. You could just grab your calculator and add these numbers up once you work them out. But I think this is kind of a clever use. So we'll have, 28 times 378 plus, and then to add up the first 28 numbers, you do 28 times 29 all over 2. Okay? So, we can work that out with calculator. 28 times 29 over 2. So, 406, and then we have 28 times 378. 10,584. Add them up, and we get 10,990, and that should be our answer to question number 21. 10,990, and that is an answer of A. All right. So there we go. That's all there is to it. And that was question 21, the very first question in Part C. Feel free to join me in the next video for question 22. If you haven't taken a look at it, I would strongly encourage you to do so. I'll see you there.